We have witnessed the end of an era. That's right, the legendary Delta IV Heavy rocket, a titan of the space industry, embarked on its final mission on the 9th of April 2024. This is a moment that will be etched into the annals of space history. What's up, spacers? This is your specialist, the Space Technician. And in a silent moment of tears, buckle up and get ready for a bittersweet journey as we bid farewell to an iconic rocket, ULA's Delta IV Heavy. After an incredible 60-year legacy, the Delta rocket family launched its final mission. And in this video, we will go over its final flight, the importance of this rocket, the Delta family of rockets, and its successor, the Vulcan Centaur. Remember, strapping in is optional, but recommended. First, let's set the scene. Picture this. It's a beautiful day at Cape Canaveral Space Force Station's SLC-37B. The anticipation is palpable as the mighty Delta IV Heavy stands tall, its 3 RS-68A engines ready to roar to life one last time. The payload? A classified satellite for the National Reconnaissance Office, known as NROL-70. Ooh, mysterious. Cape Canaveral Space Force Station's SLC-37B, or Space Launch Complex 37B, has been the home of the Delta IV Heavy since its inaugural launch in 2004. This complex has a rich history, having previously hosted Saturn I and Saturn 1B rockets during the Apollo era. The pad has been modified to accommodate the unique configuration of the Delta IV Heavy, which stands an impressive 235 feet or 72 meters tall, and weighs a staggering 1.6 million pounds, or 725,750 kilograms, when fully fueled. The Delta IV Heavy is a true engineering marvel, consisting of 3 common booster cores, CBCs, that are strapped together to provide an incredible amount of thrust. Each CBC is powered by a single RS-68A engine, which is a liquid hydrogen, liquid oxygen engine developed by Aerojet Rocketdyne. These engines are an upgraded version of the original RS-68 engines, featuring improved thrust and efficiency. When all 3 RS-68A engines ignite, they generate a combined thrust of over 2.1 million pounds, or 9,420 kilonewtons, which is equivalent to the power of 15 Boeing 747 jumbo jets at full throttle. This enormous thrust allows the Delta IV Heavy to lift payloads of up to 62,540 pounds, or 28,370 kilograms, into low Earth orbit, LEO, and 30,440 pounds, or 13,810 kilograms, into geostationary transfer orbit, GTO. The countdown began and the excitement was building. At T-7 seconds, the ignition sequence commenced. The starboard booster engine roared to life, followed by the port and center engines at T-5 seconds. This staggered ignition sequence helps to minimize the stress on the rocket's structure during liftoff. As the engines ignite, a massive fireball engulfed the rocket, creating a stunning visual effect that has become synonymous with the Delta IV Heavy. This fireball is caused by the hydrogen burn-off system, which is designed to dispose of any excess hydrogen gas that may accumulate around the engines during the ignition sequence. The hydrogen burn-off system consists of 4 radially mounted burn-off nozzles, or sparklers, which ignite the hydrogen gas and create a controlled fireball around the base of the rocket. At T-0, the Delta IV Heavy lifted off from the pad, its 3 RS-68A engines propelling it skyward with a thrust-to-weight ratio of 1.23. As the rocket climbed through the atmosphere, it left a stunning trail of fire and smoke in its wake, a testament to the incredible power of its engines. About 4 minutes into the flight, the strap-on boosters exhausted their fuel and separated from the center core. This marked the end of an era for these boosters, as they fall away from the rocket for the last time. The center core continued to burn for another 90 seconds before it too separated from the second stage, known as the Delta Cryogenic Second Stage, DCSS. The DCSS is powered by a single RL-10B2 engine, which is also a liquid hydrogen, liquid oxygen engine developed by Aerojet Rocketdyne. This engine provides the final push to place the payload into its intended orbit. The payload fairing, which protects the classified satellite during the initial phases of the flight, is jettisoned at approximately 6.5 minutes into the mission. As the second stage engine ignites, the live webcast ends, ensuring the secrecy of the NRO's payload. While we may not know the exact details of the satellite, it is believed to be an advanced electronic intelligence ELINT gathering satellite, possibly part of the Orion or Mentor series. These satellites are equipped with large, deployable antennas that can intercept and analyze electronic signals from Earth, providing valuable intelligence to the NRO and other government agencies. The Delta IV Heavy has been a reliable workhorse for the NRO, launching numerous classified payloads over its 16-flight history. Let's take a moment to reflect on the Delta rocket family's incredible legacy. The Delta rocket family's legacy spans over 6 decades, with the first Delta rocket launching in 1960. Since then, Delta rockets have been instrumental in numerous groundbreaking missions, from early communication and weather satellites to interplanetary probes and commercial payloads. One of the most significant milestones in the Delta family's history was the introduction of the Delta II rocket in 1989. The Delta II quickly became a workhorse for NASA and commercial customers, launching over 150 missions with a remarkable success rate of 98.7%. The Delta II was instrumental in the deployment of the Global Positioning System (GPS) constellation, which revolutionized navigation and positioning services worldwide. The Delta IV family, which includes the Delta IV Heavy, was developed as part of the U.S. Air Force's Evolved Expendable Launch Vehicle (EELV) program. The goal of the EELV program was to provide assured access to space for government payloads while reducing launch costs and improving reliability. The Delta IV Heavy, with its unique triple-core configuration and powerful RS-68A engines, has been a key player in launching high-value classified payloads for the National Reconnaissance Office (NRO). The rocket's impressive lifting capacity and ability to reach high-energy orbits have made it an indispensable asset for national security missions. The Delta IV Heavy in particular has been a favorite among space enthusiasts and photographers alike. Its unique orange foam insulation and the massive fireball it creates at liftoff make for some stunning visuals. Photographers from the NASA spaceflight team were on hand to capture the rocket's final moments, sharing their incredible images in near real time. It's a bittersweet moment, my friends. As we bid farewell to the Delta IV Heavy, it's important to recognize that this ending also marks a new beginning. United Launch Alliance (ULA), the joint venture between Boeing and Lockheed Martin that operates the Delta IV Heavy, is already looking to the future with its next-generation rocket, the Vulcan Centaur. The Vulcan Centaur, named after the Roman god of fire and the mythological Centaur, is designed to build upon the successes of the Delta and Atlas rocket families, while incorporating cutting-edge technologies and materials. The rocket will feature a new first-stage engine, the BE-4, developed by Blue Origin. This liquid methane, liquid oxygen engine promises to deliver improved performance and cost-effectiveness compared to the RS-68A engines used on the Delta IV Heavy. In addition to its advanced propulsion system, the Vulcan Centaur will also introduce innovative manufacturing techniques, such as 3D printing to reduce production costs and improve reliability. The rocket's modular design will allow for greater flexibility in mission configurations, enabling ULA to serve a wide range of customers, from government agencies to commercial satellite operators. The Vulcan Centaur's inaugural launch was on January 8, 2024, and we're ready to see more of its missions. As the Delta IV Heavy passes the torch to this new generation of rockets, we can look forward to a bright future of exploration and discovery. So there you have it, space fans. The final flight of the Delta IV Heavy was a resounding success. a fitting end to an incredible era of space exploration. As we close this chapter in history, let's remember the amazing feats of engineering and the dedicated professionals who made it all possible. Thank you for joining me on this thrilling adventure. Don't forget to like, subscribe, and ring that bell for more exciting space content. This is the Space Technician, signing off for now. And I'll see you, Space Cowboys, in the next one.